Okay, so we've established that this was not an experiment with respect to the concussion spit test, that it was an observational study with some survey aspects in it. Because they were not interfering, they were not able to establish cause and effect, but inference. But let's say that we come up with an experimental treatment and we want to test its effectiveness. I wonder if there's an essential oil that can help. And a researcher wants to design an experiment to see if the application of essential oils, specifically tea tree oil, will effectively reduce the recovery time from concussions. Here's a reminder of designing an experiment. Take note of the essential elements in a good experiment design. I'll call it CRR, which we will detail here. And this is called a completely randomized design. And the point of that is that everything, the way we decide who goes into what groups, we get 40 volunteers that say, yeah, I'll be in your little experiment. And how we decide how they're going to be split up into who's going to get tea tree oil and who's going to get what we call a placebo. Well, we're going to do that with random assignment. Okay, and I do want to make the point that these are not randomly selected. That's for a survey. I mean, if we could randomly select people to force them to be in our little study, but typically experiments get volunteers, which does limit our ability to infer the results upon the general population. It's an unfortunate situation that we're usually involved in, that we can't randomly select people to do this, but in the end, we can only say that the study can be inferred upon people like those in our study. So just keep that in mind. But we're going to randomly assign people to either go into this placebo group or this tea tree treatment group. And then once we get finished and we collect those results, then we're going to compare those. And that's how we're going to decide whether we have cause and effect here. Does the tea tree oil for those 20 people versus the placebo for this, does it show a significant difference in the length of concussions? That would be a two-sample means significance test. And you can see how experiments naturally leads into our significance test. One of the critical things, I mentioned CRR, so we want to make sure that we have a control group. And yes, we do. A group that's not getting or getting a different treatment than the other. And then R is for randomly assigning people. And there's another R for replication. And that is shown by the 20 people in each group. Imagine if we only had 2 people in each group, we would not have replication. Or one person, I should say, 2 people in the whole study, and one went into tea tree oil, the other went to placebo. Well, it would be hard to say that the difference between those two was simply because of the tea tree oil. Now, one thing we do with this random assignment is we need to be specific about how we randomly assigned people. If we're asked to design a completely randomized design for an experiment on a test, is that we just want to be explicit about how we did this. We took the 40 volunteers and we assigned random numbers to each of the participants. We sorted the numbers, and then the top, well, in this case, the top 20 went to one group and the other 20 went to another. Another way you could say that is we took the 40 volunteers, we took names, wrote them down on equal size pieces of paper, sorted them thoroughly, and then the first 20 we chose went to one group and the last 20 went to the other group. And that shows that you have done a randomized assignment. Okay, in the next video we'll pick it up with what if you want to do a different kind of experiment design. So keep watching.